happy to have you all here online, here in the room. I have to first say this talk is going to be more an experiment than actually something already fixed. But and it is inspired a bit by our last talk that Francisco Virginia actually gave here, and it has something to do with what happens when we compare artificial neural networks and natural neural networks, I assume brain, something closely related to that. And I think what happens sometimes, well, what I will try to defend here is not so much a detailed thesis. I will try to give a small solution, but what I try to defend here is that sometimes we just slip in the categories when we really try to compare the two. And then things like some people think that artificial neural networks are already minds or actually good simulations of the brain, and others think they cannot be because, as Francisco, for example, argued, they're just mathematical entities. And I think we have to have a closer look how certain things in the natural and artificial worlds actually relate. And I cannot. Yeah, okay, so that works. So what is the structure? So I give you a very brief, I will use more or less Francisco's idea about what an artificial neural networks are. So, but very broad, not in the detail as Francisco did last time. And then I want to talk a bit about how we can think of the mapping of artificial neural networks to natural neural networks. Okay, that doesn't mean that I'm saying it's like this is that in the artificial world and this is that in the natural world, and they're equally. I'm just saying, okay, when we talk about this, we create certain relations, okay, and I want to talk a bit about these relations and what I think is problematic here. And in a third step, I'm going to introduce something which is called predictive processing, which is from cognitive science. It's basically the idea about what the brain does, okay, in perception and cognition. And I think that can offer us a way out, actually, all those problematics of comparing artificial neural networks. Obviously, there are still many doubts, okay, and this is why the fourth point is called, is there a solution? Because lots will depend on certain things of equivalence and adequacy and so on. But this is a thing I cannot really discuss here yet. I think we are far away from actually having a solution here, but I think the question is more, is there a solution possible, okay? So, like I said, I took Francisco's adapted version from Berner, Gross, Kutiniok, and Peterson, and of how artificial neural networks are mainly described. You can see the artificial neural networks have different layers, okay? First, which is not on the scheme, is we will have an input into the first layer where you have some processing that will create an input for the second layer and so on until you get to the last layer and you're going to get an output, okay? Most important things, and like I said, Francisco gave a much more detailed talk on how that actually works. And you can have a look on it online if you're interested in knowing this. But for my talk, what will be important is that there are probably two consequences of this. Okay, first of all, artificial neural networks are inspired by the human brain in a certain sense that they want to simulate something, at least to correspond to certain things that happen in the human brain. But at the same time, artificial neural networks or artificial neurons are mathematical functions. So to say that this is what they're basically described. Okay. So now the idea of how can we map artificial neural networks on natural neural networks. I think that there's two standard approaches of mapping. Okay, again, don't see mapping as saying like this is equal to that. See mapping more like, okay, this relates in a certain sense to something that is happening in the natural world. So I think the most popular way of doing mapping is that, okay, we have an artificial neural network, and if everything goes right, then maybe it could correspond to something like a brain, okay, like a natural brain. Maybe, but this is a bit so the try, and I think we can see it also from the basic idea that supposedly artificial neural networks are in some sense inspired by the actual natural neural network for the brain. Okay, I think there's another way of mapping. This is not really exactly going to the neural network itself in the case of the natural neural network, but it's a bit the idea is that, well, if brains, you know, are the basis for minds, then cannot an artificial neural network also simulate some sort of mind? Okay, doesn't say it's the same thing or anything, but it's a relation in the sense that, well, even if it's not one-to-one, what we try to do is find something similar. At least we want to get to something like, okay, artificial neural network is capable of simulating something similar to the human mind. So I think when you think about, for example, large language models, the idea is that you have an actual conversation with the large language model where you feel even comfortable, right? It's not that it gives you a very static ratatatata answer. It gives you actually a really nice answer. Usually when you put it in ChatGPT or Gemini, it doesn't matter if you ask him something, and it says like, even, you know, it says like, oh, sorry, this was wrong for my part, and I give you a better solution for this, and so on. So the conversation it's tried to be as natural as possible. So there is a tentative of simulating at least certain aspects of the human mind. Okay, I want to say it's like, okay, this is not going to, I'm not going to try to convince you that anything here solves the problem of intentionality or consciousness. I'm just saying that some relation is the idea. Okay. However, I think there might actually be a problem. Okay, this is what I want to talk about a bit more, or this is what I want to think with you about in a bit more detail, because I'm not 100% sure that everything I'm saying here is already completely right, but I think there is definitely a problem. For example, what I'm saying is the description of artificial neural networks does not correspond to either of the relations, because it seems that to be a description of a description of what artificial networks do. So basically how they work. Okay. So it's not so far when you go back to the idea of the scheme that I showed in the beginning. For me, the scheme is not so much about, is this artificial neural network a brain or not? It basically says more like, how does an artificial neural network simulates what a brain does? Okay, and theories in neuroscience for me seem not to be exactly about that. I'm not saying that there is no branch in neuroscience where you actually look at what brains do, but I mean, if you look at the biological idea of neuroscience, is they look inside and they want to tell you what a neuron is. They want to tell you that there's a potassium potential doing this and that, there's neuron firing and so on and so on. And I think this is not the description level of artificial neural networks. So I think there's a mistake in mapping thing. And in the second case, in the mind case, it's the same thing. It's the artificial neural network description does not tell you really anything about how minds work. It tells you how brains work, or artificial brains in this case. Okay, so the output, for example, maybe I can go to the next slide just to see. So the output, for example, should be something like this. Okay, The computer is more the physical component that in some sense corresponds to the brain. Of course, in the case of the computer, it's more difficult because there probably are some virtual issues involved as well. So, for example, we have to probably think about how artificial neural networks are implemented in the operating system and so on. So it's not a one-to-one idea, but in the end, what you want to talk about is yes. So the idea would probably be a bit like, okay, what you want to look at when you look at biological brains, you want to look a bit in the computer in the same sense, right? You want to do what the computer is. If you're a functionalist like I am, what you want to know is like, are they functioning in some sort of way equivalent, and could they implement certain things equivalently? Okay. So then you have the schemes of artificial neural networks, and for me, it's that's the questions. What does that actually correspond to in our theories about natural brains and minds? Okay, because when we go to the other the second correspondence, which I talked to you about before, is like the output of the mind. For example, when you're talking and I'm waving my arms and so on. It seems that that's more when we look at the level of what a large language model is. Okay, so how does it give us? Does it give us a nice answer, or is it a biased answer, or so on? But it's not on the same level of the artificial neural network. So the question for me is like, can we make this in a sense? Can we make sense of this? Okay, can we make sense of this, and what would the artificial neural network scheme actually apply to? Well, unfortunately for us, there are theories about how cognition and perception works in cognitive science, and the most recent one is, let's put it like this, relatively close to an idea of generative models. Okay, so generative AI. So the idea basically is predictive coding or predictive processing, which is a very general idea. It basically tells you only what brains does, what brains do. Okay, but the idea is that this framework basically turns traditional approaches to cognition and perception upside down. While traditional views assume that perceptual information travels up the cognitive hierarchy. Okay. Where it's centrally integrated into a representation of the world. Predictive processing argues that fundamentally there is a flow top down. Okay, doesn't mean there's no flow back up, but fundamentally it's top down. This means the brain is essentially a large prediction machine. Okay, the brain basically predicts the world, which tests its models against incoming perceptual information. That's the information that travels up, but it only travels up when the model is wrong. Okay. And for some, this means perception is now very virtualist and maybe even considered like an online hallucination. So basically it says, you're hallucinating the world as long as your models are right. Okay, and as when they're wrong, basically there's new information coming up, and they're going to then either create new models or get rid of the error in the model. So predictive processing is basically the idea of the top-down information flow. The brain is a hierarchical prediction machine that constructs models. And as I said, they are generative models of the world. So basically, your brain is creating the data, okay? It's not just implementing the data. And the brain on this model is conceived of as a suite of mortality-constraining hierarchical optimized prediction machines, all constantly involving in anticipating sensory impingements. So perception is theory land. Basically, you already have a theory about the world when you perceive. Well, you can see some indicators down here where you can find this. Okay. Predictive processing is very big at the moment, so you can find a lot of literature on it. Probably the best to start is vanilla predictive processing for philosophers. I think that's by Vanja Wiese and Thomas Metzinger. Gives you a very nice introduction to what predictive processing is. But there are many ways of thinking about this situation. So just to basically tell you in the end again here the thing about that perception as an online hallucination. The important part is that the perceptual sensory inputs are now error signals. Okay, they're not they're not creating the model in itself. They're basically only there to well, in a certain sense, correct the generative models already done by the brain. And sometimes what is very important is to explain that the generative model, in a certain sense, can more or less be adequately used to describe the world, and all the errors are tried to be held that come back, the error information that come back is tried to be held on the most lowest level of the model. So only the big problems actually rise to levels where you might actually be conscious of them. Okay? Most of the other ones try to keep it the lowest level possible. So again, this is a duplex architecture. So you have the top-down primarily, and you have to error information traveling up, which means basically the prediction model is always tested and refined against these perceptual signals. So the question that I would have to say now is, if we go back to here, this one, is could we say that the schemes of, or how we describe artificial neural networks is that not more likely to correspond to something what predictive processing is doing? So basically tells us what the brain does, not what the brain is, but what the brain does. Okay, and it is interesting to see, and this is not only coming from me. I had very nice talks with a philosopher and computer scientists from the University of Southampton, who wrote actually an article in our book, The Mind Technology Problem. It's called Predicting Me. His name is Paul Smart. And there he basically says, if you do mind uploading, what you actually want to do is not implement any of the higher level, which is the mind, and not any of the lower level, but what you want to do is you want to implement the models that the brain is actually doing. So basically, what corresponds from the artificial neural network to the brain is this idea of what do both systems do. Okay, and I think that coming back here, that might actually be a solution for solving this problem about, or might be a step in the right direction for solving the problem about, can certain artificial neural networks be considered a good simulation of the brain, and also can, in the end, artificial neural networks also be considered a simulation or even an actual mind, even though they are basically just only mathematical models and structures. But if we consider that the brain also is only doing models and structures in a certain sense, then there might be the possible idea that if certain mental properties emerge from brains who do generative models, why wouldn't there be certain mental properties that could not emerge from what computers / schemes of artificial networks do? Okay, and I think there are two big questions to be answered first. First is PP the right kind of way to describe what the brain does? So is predictive processing really the theory? At the moment, many people subscribe to it, but it has its problem. So probably have to discover more things on that front. And then the question would also be, is really the predictive processing scenario and the schemes of artificial neural networks, are they really equivalent? Or, I mean, they seem to be on the first, like I said, in a very quick, superficial way they seem to be, but when you go into depth, they might not be, okay? This is something we don't know yet, and we probably have to investigate a bit more. But at the same time, I think it gives us at least a starting point for a solution, okay? So the solution would be, we can implement, we can actually do the right correspondence from artificial neural networks to natural neural networks, considering certain things. Again, I just want to say, and I wrote this as a waiver, this does not solve the problem of more difficult ideas such as consciousness or intentionality. It's more the idea that what can count as mental properties or so on. And one of the reasons I would do this, put this waiver, is because it's already a very complex problem of actually solving whether other minds have intentionality or consciousness, because I mean, we're assuming this by basically empathy, but knowing for certain is a complex and old problem in philosophy of mind, which is to the day unsolved. But I think this is a problem that already exists, and we can ignore it in a certain sense, at least for now. And I know I was a bit quicker, but that gives us some time to talk about this.